All right, everybody. So we're going to take a look a little bit at our frequency distributions now in Chapter 14, are looking at data. So frequency distribution is all about making sure that we have a way to organize numerical data in a way that makes sense and is very usable, and then being able to graphically represent it. So the graphs that we talk about not only provide a way to sort of display the information in a little bit more interesting way, but they also allow you to find patterns a little bit easier because you can see what's happening a little bit better. So we're going to look at these frequency distributions today. That's kind of our ultimate, our goal for the end and how we can represent them. But the textbook also talks about a few other types of graphs that I want to highlight just quickly that have to do with what we're going to be talking about here as well. All right, so for the first ones, they're called line plots. Basically, they use a symbol to show frequency. So I have an example on the next slide of one of those. It's basically, instead of having a bar, the height of whatever it is, like if you're going to do a bar graph, they show a picture that represents what that looks like as well. So it's the little football means one win. So being able to look for, okay, yep, there's a key there that tells me how many. If the football was worth a different amount, it would change the values for each of these. So some people like these sort of line plots because it's a more fun way maybe to see it, and it visually represents with what we're doing, and you can draw conclusions. You know, how many teams have won only one? How many have won the same amount? Things like that. The next kind of graph that your book talks about are the two different types of bar graphs. So single bar, where it just shows the frequency, how many with each bar. So frequency means how much, how often it occurs. So you're familiar with regular bar graphs. They can be vertical, they can be horizontal. They compare, though. It's a way to make comparisons between numbers. Double bar graphs would be where you're comparing two sets of data. So say you have male and female, and you want to look at both category within a category. So say you're looking for how many kids play sports at Hastings High School. So how many kids play basketball, soccer, swimming, things like that. You could break it down to how many boys versus how many girls within each of those categories, and you could make a comparison. So that would be a great example of a double bar. You could do a quadruple, how many freshmen, sophomores, juniors, and seniors are participating. So you can do a lot of different breakdowns. One kind of bar graph that maybe you haven't seen is something called a back-to-back, and this is an example that's on the next slide here. A back-to-back bar graph is one where they are showing you the two bars, but instead of being next to each other like a double bar, they put them back-to-back, just like you would stand back-to-back with someone. So the bottoms of the graph are together, just like if you're standing back-to-back. Your bottoms are together. So when we look at those, they're going to the left and to the right. So this graph is showing information that you can compare, but just horizontally back-to-back instead. So the trends here are not boding very well for us in the U.S. This is from the Wall Street Journal. Over time, seems like the number of hours per work increasing. The number of hours of fun or leisure is definitely decreasing, but just a different way to represent that information. But what we're really going to talk about today is the frequency distribution, what that is. So sometimes the words really get in the way for people. Frequency just means how often. Distribution is how they are spread out. Where are these numbers? Where are they located? Are they close together? Are they far apart? So how are they distributed? So frequency distributions are just basically a table, some sort of a table that's used. I'll say table here so we know. It's a table that's used to organize data when a traditional bar graph wouldn't be appropriate. So the categories that we're actually using are intervals of numbers, not just like content things. Like the example I gave before, how many kids play, basketball, lacrosse, tennis, whatever. Those aren't numerical data values. Those are basketball, lacrosse, tennis. Those are items. So we're talking about the kinds of data that would be organized with numbers. So for example, say you're looking at organizing how many kids play youth sports in different age brackets. So how many kids that are between the ages of 5 to 10, and then the kids that are 10 to 15, and then 15 to 20. That would be the kind of information we would organize in a frequency distribution. By those intervals of numbers. Now, the really important thing about those intervals then, we call them the class interval. So class meaning kind of like grouping, just like you have classes that you go to. So like first hour, second hour, that's a class. They're meant to be together for some reason. A class interval, it has to do with what numbers are you grouping together. So in my example, I said all the kids that were ages 5 to 10, 10 to 15, 15 to 20. That means the length of my interval is 5, right? I have 5 ages in each one. That has to be a uniform length. You can't make a histogram or a frequency distribution and have the intervals be different lengths, because then you're not comparing the same amounts of stuff. So each of those bins or intervals has to have the same amount in it. So the length of the interval has to be uniform. And when we do that, when we say our intervals, we're writing them in interval notation. The first one has to be closed bracket, meaning included, the bottom bound, and then the upper bound, the upper limit, is not included, parentheses. So when you think about what that means for when we write them, when we're tallying or organizing our data, the lower bound's included, the upper bound is not. And I'll show you that when we get to our examples. All right, so let's take a look at a set of data that's organized in a frequency distribution. So this is a set of weights of a whole bunch of boys from a wrestling meet. So this entire table that you're seeing here is the frequency distribution. So when somebody asks you to make a frequency distribution, or if you're going to organize in that, that's what this table is. So what does a frequency distribution give you? Well, the first column here, these class limits, those are actually the intervals that we're talking about. And if you notice, they're all the same length, 80 to 90, 90 to 100. They're all the same length. And those are the weights that these wrestlers are. So all the kids that weigh in the 80 to 90, 90 to 100, and so on. And when we do our intervals, remember, bottom is included, upper bound is not included. So if that helps you to think that, you don't have to write it all the way through. But if I was 90 pounds, wouldn't that be great? If I were 90 pounds, I'd be very much younger than I am right now. Where would you tally my weight? Well, I'd have to be in the 90 to 100 category because the lower bound is included. So kind of keep that in mind when you're doing your tallying if you're doing it on your own. So they must have taken a set of data, tallied up how many people belonged in each one, and then what does this column on the end mean with the F? Well, F stands for frequency. So, if I could spell that, that would be awesome. So frequency, oh boy. You can go back and that's a cue. So frequency, that's how many in each category in each interval. So for the 80 to 90, that means I have 2 boys that would have been tallied in the 80 to 90 for their weights. 3 of them were in 90 to 100. 6 of them were in 100 to 110. So it's telling you how many kids. If you total all of those up, should be the 76 that you had. So that gives you the total number of people or scores or numbers that are in your chart. Now, nowhere in this information are you actually given the actual data, like the real weights of these boys. We do not have the roster with their weights, but what we do have is how many were in each category. So that kind of brings us to our next issue. What if we need to have a number for these boys to represent the boys in those intervals? Those are called the class marks. So the class marks are the place where we have the middle of the interval. So the class mark is the middle value or the middle score in an interval. So in this situation, we talk about what kinds of values those are going to be and what that's going to look like. The middle score in an interval then would be for our 80 to 90 would be the score of 85. And then from 90 to 100 would be 95. And then 105 and on down the line. So what we can use that for then is we can use that to represent the interval. We're going to do that in a couple ways. One is we're going to be taking a look at what kinds of numbers we can use to graphically represent it. So if we don't have the actual data, how can we record it on a graph? And then the other one is we're going to take a look at and be able to figure out things like average or median, middle score, if we know kind of a number that stands for it. So if we don't have the actual data, can we use the class marks, that middle score, to be able to represent those data values? So it's a really nice way to have a number that represents it. I don't know what they actually weigh, so I'll use that score instead. Okay, before we go on to actually the next example, I want to go back and talk about our next 2 pieces. All right, so the picture representations of what this data looks like. So the first one is the bar graph version, which is called a histogram. So if you take a frequency distribution and represent it as a bar graph, they're called histograms. So basically it looks like a regular bar graph, but instead of having like the categories down, ooh, that's pretty blue, categories down at the bottom, they have the intervals of numbers. So going back to my example, so the kids in youth sports, if their ages 5 to 10, 10 to 15, 15 to 20, things like that, those would be the intervals across the bottom. So the width of each of the bars would be the width of the interval, so they would be 10 or 5 long. The height then of the bar is the frequency, how many people are in each of those intervals. So when you do this bar graph, you have the intervals across the bottom, each of them a uniform length, and then the height will be how many are in each of those. So that's the bar graph version. Well, you can do a line graph instead. So that's called a frequency polygon. Kind of a weird name, frequency polygon, but basically it's a scatter plot or a line graph where you connect the dots that would show the trends instead. So in order to make that line graph, you use those class marks I was just talking about. So that middle score that represents your data set, we use that to represent the the data so we have a place to actually make that scatter plot. So I'll show you that in that same example we were just talking about. So the one that we just did with the wrestlers, we're going to go ahead and make a histogram for that data. So we're going to cheat a little bit here. I'm going to do a broken scale just because it starts at 80 and I don't want to have to go all the way out there. Make sure you show that if you're going to do a broken scale, and just be very cautious. It can be somewhat misleading if you show broken scale, especially on your frequencies. Don't do it there, but for us, for the limits, I think it's okay. Because this is a histogram and each of the intervals have to be uniform length, what you want to do is you want to have the intervals of your graph be the length of your class, each of your classes. So when we do these, we're going to be going, up by 10 each time because that's my class interval. So each of these will go up by 10. And 170. All right, so these are the weights. And then on the Y, or the vertical axis, that's going to be your frequency. So a lot of people just say F for frequency. Some people say number of people, however you want to do that. Our largest score is a 20, so I think I'll go by 2s. So we've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So do what you can as far as scale goes to be able to represent that well. All right, so for our class limits then, the first one goes 80 to 90. There's 2 kids represented in that interval. So we have the 2. So that would be our first one. Now here's a difference between regular bar graphs and histograms. In a histogram, your bars have to be connected because the one interval ends at 90, the next one starts at 90. They are connected. There's no space between your bars, which could happen if you do that example I talked about before, like all the kids that play basketball and tennis and hockey and lacrosse. Those would probably be separated, right, to have space between those categories because they're just separate entities. These are numerical values that go consecutively in order. So our next one, which is going to be the height of 3, has to be connected. Okay, then we have a height of 6, and then we have a height of 12, and then we have a height of 20, and then 18, trying to make these straight, getting a little bit crooked here, and then 11, and then 4, ooh, that's really tiny, and then 1, sorry about that. All right, so the green, what I just made, that is my histogram. That's the frequency distribution in a bar graph format. Okay, now let's talk about the frequency polygon. So histogram is the bar graph. Now we're going to do the line graph or the scatter plot, the frequency polygon. Sounds like kind of a weird name. For the frequency polygon, what you do is you are graphing ordered pairs that are like this. It's the class mark we're going to use to represent the score, and then the frequency for the Y. So for our XY, for that scatter plot, it's going to be the class mark, which was that 85, 95, etc. So we need a number to represent the data. I have to have a value to stand for the interval. So my first one would be the point 85, comma, how many were there? 2. So I go over 85 up to 2. That would be my first location. Then 95, 3, 105, 6, 115, 12, and so on. So we graph those points, and then we connect them as a line graph, so with line segments, and that gives us the line graph version. So you can show trends with a line graph just as easily as with a bar graph. So that's called a frequency polygon. So this set of data, probably not a varsity resting roster, probably more like middle school, right, looking at the data, and most of the kids are in that 120 to 130, a little bit smaller, but we can definitely get a nice representation of the distribution. Where are these kids located on that spectrum? Okay, so we're going to do one more example, kind of start to finish. I want to talk about how we can find out these different values. So I'm going to go ahead and put this up here so we can look at this. So we have this set of data of speed. So to think about some of those things that you pass on the road that shows you your speed. I've heard the rumor, I've never experienced this personally, of course, but that it flashes red if you're going too fast above the speed limit. I, of course, have never seen it. Maybe you haven't either, but some people have. But anyway, it tells you what speed you're going. So it's really good information to be able to look at to see how things are going on the road. So if we want to organize this ultimately into a histogram, I want you to be able to think about what would you need to do to figure out and make that happen. Well, if we're going to organize this into a histogram, we have to have intervals to be able to work with. If we're going to have intervals, we better figure out how spread out are these numbers? Like, how many intervals are we going to need to have? How many values should be in an interval? We don't really know that unless we kind of get a handle on what's going on with our data. So one thing people like to do is find the range of the data then. And hopefully you remember what range means. We're going to talk about that again. But it's the largest data set value minus the smallest data set value, which would give us, in this case, 24. So when we do histograms, we like to have at least 4, 5, 6 categories to be able to see the distribution. You don't want to have, in this case, I think there's 20 speeds recorded there, 20 different bars on your bar graph. That would be really hard to compare. They'd be all over the place. We group them together to make it more meaningful to look at. Maybe it's not so critical we know each speed separately, but maybe we want to know all the people that are going, say, 50 to 60 miles an hour, or maybe 50 to 55, 55 to 60. Can we group them together a little bit? So if you're looking at 24 as your spread of your range, well, if we want to have at least 4, 5, or 6 bars, we're going to need to have at least 5, 6, 7 miles per hour represented in each of those to make that work. So if we've got 24, 25. So you can decide. There's really no right or wrong answer here when we look at that, but we need to pick something that makes sense. So we need to determine this class interval. So I think I'm going to go ahead and do 10, just so we don't have to do quite so many. 5 may be a little bit more specific, a little bit better, and I'll show you that on the calculator, but we'll just do 10. All right, so once we do that, I think we'll figure out the rest of this. We're going to go ahead and make that. I know you guys have this on your you might have it on your sheet. So class intervals, then, if I'm going to get 59 on here, I don't want to necessarily start at 59. That's not a fun number to work with. It's totally fine to pick things that are easier. I would probably start with 50. So 50 to 60, 60 to 70, 70 to 80, and then 80 to 90. That should be able to give us everything that we need. And again, remember when we do our tallies, lower bound, upper bound, lower bound, upper bound as we do that. So I need you to go through and tally your data. So how many are in each of those intervals? Once you've made your determination, yep, we're going to do 10. Our class marks then would be 55, 65, 75, and 85. We're going to use that to help us do our polygon in a little bit, but we need to know how many are in each interval. So go ahead, pause the video and do your tallying, and just be careful for numbers like 70. Where would you put 70? Well, it has to be in the one where the lower bound is included, so it would be in that third interval. So just be careful when you tally. So go ahead, pause, and get your tallies. Okay, what I ended up getting when I tallied, and hopefully you are in the same boat, is I ended up with 1, 9, 7, and 3. So double check your tallies and make sure you're good. So this is called the frequency distribution. What we just made here is the frequency distribution. So we have our intervals and our frequency for each one of them. Okay, so now let's go ahead and make our histogram then. So this is going to be the histogram then, just getting the terminology. That's the bar graph version. So I'm going to again break the scale just so I don't have to do quite so much here. So 50, 60, 70, 80, and then 90. And then my frequencies, I think we'll just go up by ones, because we only have to go up to a 9, right? So these are our frequencies. Okay, so again, the widths of each of these have to be the same length. That's the uniform length. So each of these are going by 10. So we have 1, and again, connected, right? They're not separate. And then 7, and then 3. So what I just made in blue, that's the histogram. It shows the distribution. Now the polygon, the frequency polygon is the line graph version. So it would be the class mark 55 and then the frequency. So 1 and 9 at 65, 75 would be 7 and 85 would be 3, and you connect it with a line. So that gives you a nice representation of the polygon, the line graph version. So my question would be, what do you think the speed limit is on this road? Well, there's probably lots of different guesses, but most of the people are between 60 and 70. So you almost have to assume it's probably in the 60s at least, because most people go at or above speed limit, right? So probably 65 would be a really good estimate. Maybe 70 if you think of a lot of people that would be below that. But we can definitely see some of the distribution happening and what that would look like. Okay, if you can grab your graphing calculator, I want to show you how to enter some of this information on your calculator. So if you can go into your stat menu, into edit, and this is what I need you to do, and you can pause the, oh, those are not the numbers I had before. Very interesting. Okay, so if you can go ahead and pause and enter in your data here. So I need to clear this out. This is not what I had in here before. It's kind of interesting. I'll have to do it too. So I'm going to enter in my actual data in list 1 and the class marks in list 2. So I'll kind of write it out here. So list 1, the actual data. List 2 is going to be the class marks. And then list 3 is going to be the frequency. So if you can go ahead and pause the video and do that, that would be wonderful. Okay, hopefully you have everything in there. Now we're going to go to the stat plot menu. We're going to turn plot 1 on. So go ahead and turn your plot 1 on, and we're going to select the histogram or bar graph, which is the one that actually looks like a bar graph. When you do that, as soon as you hit that, it should go to X's in list 1. If for some reason you don't have the right list name down there, if you look above number 1, number 2, number 3, it'll say list 1, list 2, list 3. You can change that by doing second, number 1, number 2, number 3. Make sure you have the right list in there. Okay, then we're going to go to our window, and we need to set up the scale. If I just do -10 to 10, I will never see these values because they're up at 50. So I'm going to make some adjustments. I'm going to put it exactly how we had it there. I'm going to start at 50, I'm going to go up to 90, and I'm going to go by, this is the most important part, 10. The X scale is always the length of your interval. You have to set it up that way, otherwise you won't be grouping the right numbers together. And then we're going to go ahead and go 0, because my Y's aren't negative, and then to 10 would be fine. I'm going to check and make sure I don't have anything in my Y equals, and then go ahead and graph, and there's your histogram. Super cool. Now the other part we can do, go back to your stat plot, is we can do plot 2 as that line graph. So I'm going to go ahead down to plot 2, turn it on, and then my default here is that line graph. So mine is the line graph already. You want to select the one where it's the dots connected, and the X's should be in list 2 and the Y's in list 3. Those are the class marks and the frequencies. That's going to give you the scatter plot. If you go back to graph, cool, we have that scatter plot situation, so it's kind of awesome. So you can see both of them at the same time. So I need you to understand frequency distribution, how we put numerical data into intervals, and then be able to represent it graphically, both a histogram, which is the bar graph version, and then the frequency polygon, which is the line graph.